BC, verify Falcon 9 is in startup.
Falcon 9 is in startup.
T-minus 30.
All gas close complete.
T-minus 20.
Stage 1 tanks pressing for flight.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of Falcon.
And you're looking at the first stage of the Falcon 9 rocket after a successful liftoff from Kennedy Space Center. The rocket is just about to pass through max Q, which is the maximum aerodynamic pressure that the rocket will see throughout its entire flight. Normally we see a shockwave right around this time forming, but it doesn't look like there's going to be enough light to see that shockwave. Sounds like max Q is passed and we've throttled back up those Merlin 9 engines. Merlin vacuum bleed-in has started. This is when we chill down that MVAC engine on the second stage, just like we did for those first stage engines.
Back to controls we go.
We're currently looking like the trajectory looks good. There's a few events that are going to be happening in rapid succession very soon here. The first one is going to be the main engine cutoff of the first stage. So those 9 Merlin engines are going to shut off. Directly after that, a few seconds later, we're going to have, 10 seconds after that, we're going to have stage separation of the first and second stage. And then immediately following a stage separation, we're going to see the second stage engine start up. See, it looks like stage separation was successful, just waiting for that second stage to start up. And we have a successful startup of the Merlin vacuum engine of the second stage. Second stage looks nominal, and back D is looking good. Right now that Merlin vacuum engine is burning away. We're getting nominal prop and nominal trajectory from both from the second stage. Let's take it down to the floor and see what's going on.
Okay, you just saw a successful stage separation and a successful light of the MVAC engine. That's a really big really big milestone, fairing separation.
You did just
yeah.
see the
Oh,
fairing.
we just did.
Yeah.
That's awesome. Sorry, you couldn't see it. That's great. That's a huge milestone for us. So again, MVAC has started up. It's burning. We separated that fairing successfully. You know, up in the vacuum of space, you don't need it anymore, so we ditched it.
It's still quite a sophisticated system, the fairing. Apart from protecting the spacecraft during ascent and preventing excess humidity buildup and shock loads and things, it's also got a really cool system called the re-radiation system. Just like we don't want to launch our rocket if we can find something wrong with it that needs a little tweak before launch. Same with the satellite, because you've got only one chance to, well, I guess you're not able to fix it once it goes to space. So anytime before then, if you can fix it, you want to. But the fairing, being that carbon fiber composite with aluminum honeycomb, is a Faraday cage. That means you can't get electrical signals in and out very easily. And so you've got a hardware system that will take signals from the satellite, pipe them just to the outside of the fairing, and then re-radiate those signals out so that everyone can listen in and make sure that the satellite is still healthy. That's only active before ascent. In this case, we're not actually using that system during ascent.
Now, typically around this period of time, we'll be checking in on stage one. We have those onboard cameras. We're watching the grid fins. But today, again, because this is an expendable launch, we don't actually have a camera on stage one. And again, the reason we're going expendable is instead of coming back down to LZ1 back at the Cape or going down to our drone ship, Of Course I Still Love You, or just read the instructions, is because we needed to use all of the propellant that we had in order to get the performance that we needed to put EchoStar XXIII in its intended orbit. But this is like every other rocket launch in history. We've gotten used to these landings, right? But sometimes we have to do it this way. And so it's still a super awesome launch, right? So why don't we go on up to Tom and get an update from him.
Just another status update for you guys. Looks like the MVAC engine is performing nominally on the second stage. Good engine temps and good fuel consumption rates. Everything is looking really good in that second stage. Like Lauren was saying, this is a little bit different. Usually we're tracking the first stage coming down for a landing right now, but that is not happening this flight. But the second stage is doing really well, so that's really good news. We are just about halfway through the first burn of this second stage. This is an MVAC D, that stands for Merlin Vacuum D. It's the same type of engine that we have on our first stage, but specialized for the vacuum of space. This engine puts out 210,000 pound-feet of thrust. And that nozzle you're seeing on your screen right now, that red-hot nozzle, it may look small in the picture, but it's actually 10 feet long and about 10 feet in diameter. So this is a massive nozzle, a niobium alloy, radiatively cooled nozzle extension to make sure that we can get all of our performance out in the vacuum of space. Right now, MVAC continues to look good. There's a trajectory is looking really good right now, and all telemetry from the second stage is looking healthy. Right now, the Merlin vacuum is operating at just about full thrust, producing about 4 Gs of acceleration. We begin to throttle it down as the propellant burns off, just so we can keep that acceleration in check. The next big event is going to be at SECO 1, that's second stage engine cutoff 1, at about T plus 8 minutes and 30 seconds, so about a minute from now. After that first stage, the second stage engine shut off, we're going to have a brief coast period of about 18 minutes or so, and then we'll be lighting it again. So to sum everything up, the second stage is looking really healthy, MVAC D is looking really good, so just a few more minutes left on that burn. This is Tom Perderio from SpaceX headquarters, just bringing you a quick status update on the second stage. Currently, we're about to start our second engine, second burn. Should be coming up in just a few seconds here. And it looks like, as you can see, we have confirmation of a successful second engine start. This is the second of two burns, the final burn that our second stage is going to be performing today. This burn is going to last for just about 1 minute, and then it'll be taking off. This burn is necessary to get the EchoStar payload into the correct position for deployment, which will be happening a few minutes after the second engine's second cutoff, coming up in just about 30 seconds now. We're currently throttling that MVAC engine to make sure the acceleration stays within the bounds we need. And it looks like a successful termination of thrust, a successful second engine, second cutoff. Like we said earlier, the EchoStar payload is going to deploy just a few minutes from now. So hang tight, watch the animation, and we'll be right back.
All right, welcome back, everyone. We got confirmation of a successful second engine shutdown, and we know that we are now in a good orbit. And coming in very soon, we're going to have payload deploy. Now, the satellite, the EchoStar XXIII satellite, is mounted onto stage 2 of Falcon 9 via what we refer to as a payload adapter. Falcon 9's flight computer will then send a separation signal to that payload adapter. That signal will be detected via brake wires, and the satellite will actually separate from the second stage of Falcon 9. In order to give it that little delta V that it needs to push away from the rocket, there are 4 springs in that payload adapter that will give it a gentle push off on its own path.
At that point, it's going to unfurl its solar panels, start collecting power, start transmitting back to Earth, and head towards that geostationary orbit over Brazil. Now, geostationary, just a quick reminder, is where the satellite appears as if it's always in a fixed point in the sky. You can see the animation on your screen. Once the satellite gets into the right spot, that there we go, it's doing its second burn, transfer from that tight low Earth orbit into that egg shape, and then circularizing. And there you can see that line shows you that it's always floating above the same point in the ground. So that means that even if you're looking at the night sky, and usually the stars will rotate over the course of the night, the satellite will always stay in the exact same spot. Geostationary orbit is a particular type of geosynchronous orbit. The two terms often are used interchangeably. Geosynchronous just means that it passes through the same point once a day. If it isn't true geostationary, then we have a beautiful confirmation of spacecraft deployment.
That is EchoStar XXIII, having just been sent off on its way to continue along with its mission. Successful spacecraft separation from Falcon 9. And with that, actually, Falcon 9's job is over for today. Spacecraft is going on to begin its mission and begin that solar array deployment and orbit raising, but that brings this webcast to a close.
Quick recap, we had an almost on-time launch just to get around some of those high-altitude winds. First stage, successful launch. Second stage, 2 successful burns with that coast period in between. Not recovering the first stage because of the performance requirements of this mission, and that successful payload deploy that you just saw.
And just some thank yous to everyone that helped with the success today. First, a big thanks to the range for providing range safety and assets. To the Federal Aviation Administration, or the FAA, thanks for giving us our launch license for today. To our customer, EchoStar, we wish you much success with this satellite and its 15 years of service. To SSL, who built the satellite, thank you for your continued partnership with SpaceX. And to all of you out there, the viewers, thanks for checking it out. And if you want to follow us, check us out on social media. You can see us on Twitter at SpaceX. You can follow us on Facebook. And if you want to come join us here in Hawthorne at one of our launch sites, go to spacex.com/careers.
Be safe tomorrow with St. Patrick's Day. We survived the Ides of March. And a happy birthday to Einstein, who would have turned 138 this week.
Don't forget about Pi Day.
Why would you celebrate Pi Day?
Because to not celebrate it would be irrational.